Okay, now let's find the integral by partial fraction. So here's the thing, before you jump in, you have to check something. Can you see that the degree of this x is greater than the degree of this one in the denominator? So that's more like an improper fraction. So make sure that the degree of this x is always less than the degree of the one on the denominator. Okay, so what can you do now? You can use a long division method, right? And then you can come and say, okay, you are dividing 2x cubed minus 4x minus x minus 3. You are dividing it by a function x squared minus 2x minus 3. So you come and say, how many times does x squared goes to 2x cubed? It will go what? 2x. Then from there you say 2 multiplied by everything. So if you multiply everything, 2 by everything, and you subtract the results, so you will have 2x cubed minus 4x cubed and then minus 6x. So if you are subtracting these from here, you can see that this one will cancel this one will cancel, sorry, I forget 2 here, this one will cancel this one, and then you're going to have minus x plus what? 6x, because you open the brackets by the negative, and then which means you're going to have 5x and then minus 3. So this is what we call the remainder. So this is how you integrate. Now your integral will be written something like this: integral 2x plus, right, 5x minus 3 divided by this function dx. So now you can work your function, you can find the integral symbol. So you're going to have the integral of 2x plus the integral of 5x minus 3 over x squared minus 2x minus 3 dx. So this integral is very simple, but let's first try to work out this one. And remember, we must use partial fraction. And then this is going to be 5x minus 3 over x squared minus 2x minus 3 dx. Then this you can write it. You have to factorize this denominator so that you can have something like this: 5x minus 3 over x squared minus 2x minus 3. Oh, sorry, we have to factorize. So when you factorize this, you're going to have x minus 3 and then x plus 1 dx. Now, using the partial fraction, you can say integral 5x minus 3 over x squared minus 2x minus 3 dx. You can rewrite it like this: a over the first roots, which is this one, x minus 3, plus b over this part, so you're going to have x plus 1 dx. So then you can say this is equals to this. So, or you are supposed to rewrite it like this, but still the same, it won't affect anything. So now you will have 5x minus 3 equals to you can say x minus 3, x plus 1, and then a over x minus 3 plus b over x plus 1. So what we're trying to do is try to find this constant. So what you can do, you can multiply everywhere by x minus 3, x plus 1. You can see this one will cancel this one. He will remain with 5x minus 3. It is equals to, when you multiply this with this, you can see that the x minus 3 will cancel each other, and then you're left with a x plus 1. Even here you can see x plus 1 will cancel, and then you're left with b x minus 3. So now you come and find the roots. Just like you hit this and find the roots, then you will have x equals to 3. Now for x equals to 3, you're going to substitute 3 here. You're going to get 15, right? And then 15 minus 3 is going to be 8, and this one is going to be a. In brackets, you're going to substitute your 3 here. You're going to get 4. Then you divide by 4. You divide by 4. And then a is equals to 2. Then you do the same. Now you go for this other root. X for x equals to -1, then you're going to substitute -1 here. You're going to get -5 minus 3, which is going to be -8 equals 2. And then you put -1 here, this becomes 0. And then you substitute -1 here, you will get -4b. Then you divide by -4, then b, it is equals to 2. Oh, I made a mistake here. It's not 8, sorry, it's 12. Then 12 divided by 4 is 3. Sorry, I am so sorry. Sometimes, because I'll be writing this so fast, because I'm trying to avoid take a long video. So this one is okay. So then you go back here and substitute your A is and B. So then now we'll have we're gonna have integral your B, your A was 3, and this is x minus 3, and then plus this was your A, sorry, and then your B is 2 over x plus 1 dx. And then we're going to have integral, we can take out 3 outside and have 1 x minus 3 plus 2 then 1 over x plus 1. We just take out 2 outside the integral, dx. Sorry, dx also here. So here you're going to find this integral, you're going to let u to be what? X minus 3, and then you say du will be what? This is 1, it's going to be dx. So therefore that function is just going to be, this integral is just going to be like integral of 1 over u du, which is just ln u, right? Then you can bring back your x, substitute your u here, then you really this is just ln x minus 3. Then you do the same thing on this part. You're going to let it maybe to be what? U also, and say, or you can use the different letters, but I'm just going to use the same letter. Then x plus 1, then du, which is going to be like dx, and then that integral is just going to be integral of 1 over u du, which is just ln u. Then this is going to be ln, you substitute your u back, you're going to have ln x plus 1. So these are the integrals, but don't forget you're multiplying them by 3. So you're going to have like, this one will be 3 ln x minus 3 plus 2 ln x plus 1. But remember, this was the integral. We have to go back and add. Remember, we have here, you see, we have evaluated this using partial. So we also have this integral of 2x. Integral of 2x is just going to be like what? X squared, right? It's just going to be x squared. So the answer of the integral solution to this integral is just going to be x squared plus 3 ln x minus 3, then plus 2 ln x plus 1 plus a constant c. So that is the solution to that integral.